Hi, my name is Masood and today I will teach you how to scrape different types of websites. This is a 2-video series. In the first video, I will talk about static websites and the second video is focused on the dynamic ones. Before we start, you should note that this is just a training module and any misuse of the contents of this video is a responsibility of the trainee. So let's start with this question. What is a web page? Well, a web page is actually consisting of 3 parts: HTML, CSS, and JavaScript. HTML is a markup language that has been around for about 3 decades. The initial purpose of developing HTML was to show the raw text a little bit more beautiful, to decorate it. Here is an example. As you see, this word headline is surrounded by 2 HTML tags. One is opening H1 and the other is closing H1. H1 simply means that the word in between has to be shown in big size. Then we have a horizontal line and then there is a paragraph. And finally, we have a link. This tag shows the word Google on the page and by clicking on that, we will be redirected to google.com. Well, this is how the page looks like. As you see, this is much simpler than the fancy websites that we use every day. That's why the developers decided to add more styling features to it, and CSS came to existence. So CSS is all about the decoration of the web page. Here's an example. CSS code goes in between style tags. Here we define 2 classes, red and blueback. In red, we mentioned the color must be red, and in blueback, the color is set to white and the background color is blue. Then in the HTML part, we see that the H1 belongs to the class red. It means that it has to be shown in red. And the paragraph belongs to the class blueback. And here is the result. Finally, we have JavaScript. What is important in web scraping is to know that JavaScript can create new web elements dynamically. Look at this example. In this website, when I scroll down the page, as you see, new web elements are created and the page gets bigger and bigger. A web element can be any tag, like a headline, a paragraph, a link, or whatever. Now you know the difference between static and dynamic pages. In the case of static pages, all the web elements are loaded to the page at once, while in the dynamic pages, some of the elements might be added, removed, or changed when you are visiting the website. In the rest of this video, I will tell you how to get the data from the static pages, and then in the second video, we will focus on dynamic ones. So let's see how we can do the scraping in Python. Actually, there are many ways to do it. But what we are using here is the Selenium package. Selenium works like this. It gets the data from a web page and then loads them into an internal browser. It can access the web elements. So no surprise that we can extract the features of each element that we want. Do you remember this example from the HTML part? Yes, this is a simple link. Selenium lets us get this link and put it in a variable. Then we can simply do many different things with it, like getting the text of it or getting the target link. Another thing that I would like you to know is that any HTML tag might have some attributes. For example, a tag has an attribute named href that specifies the target link. It might have some other attributes as well, like the class, the ID, and so on. You can get the value of any attribute by this command. I will explain more details about it later in this video. Before we start real scraping, there are some requirements that you should set them up on your computer. First, Selenium works on Python 3 or newer versions. Also, you need to install Google Chrome. You can use other browsers as well, but in this tutorial, I will use Google Chrome, so I highly recommend you install this. Next, we need to get the Selenium package and also the Chrome driver, which is the internal browser of Selenium. And finally, Jupyter Notebook. I assume that you already have Python 3 and Google Chrome because it's so easy to get them installed on your system. And I will start with Selenium. Go to the search bar and type CMD and press enter. If you're using Mac, hold the command button and press space and then type terminal and press enter. To make sure that you have the right version of Python, just type python -- version and press enter. The version of my Python is 3.7.6, so it's good to go. Now I can install the Selenium. It might take a few minutes, so take your time. Let's install the notebook as well. As the last step, we have to get the Chrome driver. This Chrome driver is the internal browser that Selenium uses for loading the pages. So I simply search WebDriver for Chrome in Google and open the first page. As you see, there are different versions available for download. Here is the point. Open your Chrome and then go to the menu, go down on the Help and then click on the About Google Chrome. As you see, the version that I'm using is 83. So let's go back to the WebDriver page and then download the one that is compatible with the version 83. For Windows, I get this one, but if you're using Mac or Linux, you can use the others. Now we have everything that we need. So let's start the scraping. Create a new folder and change the name to whatever that you like. Then copy the Chrome driver into that folder and unzip it. Now we need to create a new Jupyter Notebook file in order to write our Python code. So I go to CMD again and change the current working directory to the desktop, like this. And then go to the folder that you just created and enter Jupyter Notebook. For the Mac users, they can run Jupyter from the terminal. To do this, they can press Command and space and then type terminal and press enter. In the terminal window, just type the commands that you see on the screen. Your notebook might look a little bit different from mine. Let's create a new Jupyter notebook by clicking on the New and then Python 3. As you see, this is a sample of a static page. So I would like to scrape it and extract the data. Specifically, I would like to pull the data from this table. So I will use Selenium to get the whole page and then narrow it down to this table and then extract the data inside of it. So I add the packages that we need to this program. Now we gotta create a web browser object using the Chrome driver that we downloaded. Then we set the page load timeout to -1. The number that you write here tells Python that it should wait, for example, 10 or 20 seconds until the page is loaded. And when you write -1, it means that it has to wait until kind of forever, until the page is fully loaded. You can run this program by holding Control key and pressing enter. On the Mac, you can do it with Command and enter. So far, when the program runs, the Chrome must be opened. And as you see, there is nothing in it. In the next step, we get the whole page content. Now if you run the program again, you'll see that the browser opens up and then it shows the content of the page that we set. So far we could load the page successfully. Now we have to look for the elements that we want. There are many ways to do it. For example, right-click somewhere on the table that you want and then click Inspect. In the right panel you will see the source code of this website. If you move your mouse over the HTML tags, you will see the connection between the tag and the web element in the page. I go over this table tag to get the whole table. As you see, it has a class attribute, which its value is table data, so I can use it to grab its contents. To do this, I use one of the WebDriver functions that is called Find Elements by Class Name. You can also find the elements by other specifications, such as name, ID, and XPath. In this example, since the class name has been set, perhaps the easiest way to grab the data is using the class name. Find Elements by Class Name returns a list of the all web elements that are labeled with that class name. So for accessing each element, we need to use an indexing number, like this. Now let's do something fun. Let's print out the text of the table. Here we got the text, but hold on. It's not the table that we desired. Actually, there are two tables in this page, and this text belongs to the first table, but we need the second one, so I will change the indexing number. And here we go. But it's not what we really need. We want to get the data of the cells one by one, such that we can store them in a database or in a file. So far we got the whole table and store it in the table variable with index 1. As you see, this table is consisting of 4 rows, and each row is created by a tr tag. So we can find all the tr elements by their names. Let's print out the number of the rows. And also we can see the text of the first row, for example. Now we have all the rows separately, but every row is consisting of 5 cells. Each cell is created by a td tag that we can find it by its name. For example, I do it for the first row. So in the cells variable, we have the contents of every cell. For example, if I want to print out the text of the first cell, I can use the index 0. Still, there is another question. Is there an easy way to explore the whole data of the table? The answer is yes. We can do it with a for loop. In a loop, we repeat a set of operations. The number of repetitions is equal to the number of the rows. In other words, for each row, we get a content. We know that this content is consisting of a few cells, so we need another for. The second for loop is for exploring the content of the cells. Inside of the smaller for, we can print out the content of the cells individually. But a better idea is to store the data in a CSV file. To do it, first you need to add the CSV package to your program. Then open a new CSV file and add a new writer. Now you're able to write new rows in the file that you just created. Don't forget to indent the for loop. Now we can remove the internal for and then just write new rows in the CSV file. When running is over, you can go to the folder and check out the CSV file. And here we go. In this video, we scraped a static website. Thanks for your attention, and please don't forget to check the second video for dynamic sites.